hear again from Speyer. Speyer, do you have any questions for us?
No, not for now.
Okay, fantastic. Please stand by. Parque de las Ciencias, do you have any final questions for us before we make the connections?
No, everything is okay, thank you.
Okay, excellent. Just please stand by in the control room. Thank you for the demonstrations, and we'll be back with you as soon as possible. Okay, we'll see you soon.
In-Flight Call zu tun. Wir sehen das
This is Mission
amerikanische
Control
Labor.
Houston, Space Station Commander Dan Burbank, working on board the complex, speaking with the Capcom, or spacecraft communicator Josh Matthew here in Mission Control about coordinating where things are located on board the station.
Kommen irgendwelche anderen Beiträge. Und man kann also auch den Sprechfunkverkehr mit den Astronauten dann verfolgen. Wenn die Astronauten mal nach Hause telefonieren wollen, so tun sie das mit einem Telefon.
ESA Tech, this is Mission Control Houston. Please call station for a voice check.
Station, this is ESA Tech. How do you hear me?
Read you loud and clear.
Well, hello, André. Thank you for having us on board the ISS. You are now connected with approximately 1,600 children in Nemo, the Netherlands, Speyer Technik-Museum in Germany, Parque de las Ciencias in Spain, and the National Space Center in the United Kingdom. They're really excited and ready to hear all about the Spaceship Earth event. Please go ahead.
Good afternoon, everybody in the United Kingdom, and guten Tag, alle Leute in Deutschland. I'm very pleased to have you all here in this weightless environment, and it's fantastic. I'm here in the Columbus module. This is a unique place for science. We do a lot of research here. You can see all the wrecks around me, and of course, this is the place for Europe. We have a part here, and we have a part now also with ATV on the other side of the space station, an unmanned cargo ship which is docked to us. And well, here is where we do all the science, and here is where I did, for example, your experiments, what you just saw. I have the equipment here, which you saw on the films. The fantastic foam experiment, and it floats. And also, of course, Evo convection, which I have here, which is a very nice one. You know already what it means, weightlessness. It has a lot of effect on all the things that we're doing. For example, in the convection, you saw that there is no convection in space. This means, in practice, that we, for example, have no convection of warm air going up and cool air going down, which means that heat is building up around equipment, for example. So we have to find other ways to cool it with certain cool plates, with cold water, and of course, we have to force ventilation. Because no convection also means that the CO2 that I'm breathing out, for example, is hanging around me, and that could cause a headache. So we have to force the convection. I will not talk much longer because you are curious. You have a lot of questions. So please go ahead with the questions.
Thank you very much, André. We'd like to go to Nemo in the Netherlands. Can you ask your first question, please?
Hi, André. I'm coming from the Netherlands. Is there a difference between the circulation of blood on Earth and in space?
Well, hello there in Amsterdam. Yes, there is, because normally a lot of blood and fluid is in the lower part of your body. When you're standing up, you know it. When you wake up in the morning, people have a thicker face because the fluid is a bit more distributed. In space, this is very strong. The fluid is more distributed over the whole body. So you have a thicker face, and they say chicken legs and puffy face. And so it means also that there's another circulation going on in your body. And your body is even getting rid of some fluids because you don't really need it until the moment that you come back. So there is a change. The muscles from your blood vessels and then your heart, they get weaker. So we have to do a lot of sports to stay in a good condition to come back. Because yeah, I'm staying here for a long time, but I have to go back as well. So there is indeed a change of circulation.
Thank you very much, André. We'd now like to go to Germany. Your first question, please.
This is Gerhard Daum with astronaut Reinhold Ewald at the Technik-Museum in Speyer. Hello, André. Here's our first question.
Hello, André. My name is Sina. I have a question.
Speyer in Germany, we're having a problem with your audio. Can you please check your mute?
Calling STech from Speyer. Do you hear us?
André, on behalf of Germany, I'm going to ask their question. How do you follow the results of your experiments? We hear Germany now. Germany, can you please ask your question?
This is Gerhard Daum with
astronaut. What I'm doing here are, of course, part of a big set of experiments. The scientists on the ground do a lot of research on the ground as well, and you need a lot of data points. The results take a long time. The scientists get the data down. Sometimes we bring down a disk or a tape, send it down electronically, and then they have to analyze it. A lot of scientific work is analyzing. What do I have? What does it mean? And think about it. So it takes a long time. And after our results, people tell me, I get a call or email, and I get information. And of course, with all science, there are documents written and articles, and that's where everybody can read what the results are. So that's how we get the results of science.
Thank you, André. We're now going to Spain. Spain, can we have your first question, please?
Hello, André. I'm Carolina, and my question is, can you light a candle inside the space station? What's the shape of the flame with no gravity? Will it remain on indefinitely?
Very good question from you in Granada. Yes, we can have fire here on board the space station. That's of course a dangerous situation, so we are very well trained for that. We have fire extinguishers. But the funny thing with the fire is we do also experiments with it, and we have a special box, totally isolated, so it's safe to have some combustion, to make some fire inside. And you don't have a real flame, because flame means, like we had earlier, convection, or the hot particles go up. In space, nothing goes up. So what you see, that there is a bluish dome around the fire source. And because there's no convection, it also finishes soon. It does not burn forever because it needs oxygen. It needs oxygen from the outside. And if there's no flow, because there's no convection, you easily see that the flame doesn't burn so long. But it can happen. That's why we have well trained for it to prevent. The materials are very good here. We don't get fires here, but if we have it, we are trained to take it out.
Thank you, André. We're now going to the United Kingdom. Your first question, please.
What is it like to squirt water and catch it in your mouth?
Good question. Well, I have an example here. This is water. We have, of course, our food and water contained. It has to be a bit sticky, and water has to be in a container like this with a straw. And I can show you what it means to have free water. You have to be very careful with water. It's nice to play with, but you have to have towels around. Also, when you wash with wet towels, because of course the free-floating water is nice to see, but it's of course dangerous for electronics and things like that. So therefore, we have all these straws with clips on it. But yeah, this is what happens with water. You can drink droplets from the air.
Thank you, André. We're now going back to the Netherlands. Your next question, please.
I'm Mark from the Netherlands. On March the 8th, there was a strong solar storm. Did you notice anything from the ISS?
Absolutely, and it's actually one of the most beautiful things. Because of the solar storm, we are in a period where the sun is very active. That happens every 11 years. And that means a lot of radioactive particles come to the Earth, and they are caught in the magnetic fields. You know, from the compass, there's a magnetic field around the Earth, and the particles are caught in there, and they enter the atmosphere near the poles, North Pole, South Pole. That causes light, and that is the northern and southern light. And that is a beautiful sight, greenish, sometimes with red or purple. And it's beautiful. It moves fast. You can see it very well from the Earth. If you are, for example, in Canada or Scandinavia, you can see it there. And we see it also below us because we are 400 kilometers and northern light is, for example, at about 100 kilometers. And it's a beautiful phenomenon. So we can see the solar storms, but it's radioactive particles. So it means also that we get it. So you see sometimes light flashes because of the particles, but it's beautiful, so we can see the solar storm effects.
Well, thank you, André. We're now going back to Germany. Germany, your next question, please.
Yeah, second station. I hope you hear us now.
Yes, we hear you. Go ahead.
Okay, we are here with 230 pupils, and they are listening with great attention. Okay, great. Paul, go ahead.
Hello, André. I'm Paul. What is the most exciting scientific experiment for you?
Yeah, that's a good question. Difficult question because they're all very interesting. Some experiments I hardly have to touch because it happens indirect. I have to put in some containers and then it goes automatically. But there are other experiments that you have to do a lot. And one of the things I like very much is an experiment where we use ultrasound, echo machines, to look through the heart, for example, or other vessels, blood vessels. And it's very nice because we work with the echo, with the probe, and then it's very nice to see the heart beating in the body and see all this the blood flow. I like that very much. So that's for me one of the most interesting experiments to do.
Thank you very much, André. We have a technical issue with Grenada at the moment, so we're gonna go to the UK. The UK, your next question, please.
Hello, André. My question is it cold on the ISS?
Well, you see me, I'm wearing a t-shirt, and it's actually very nice. I like it a bit cool. Normally it's about 23 degrees Celsius, but it differs in some places. It's a bit warmer than in other places. Close to the fence, where the air comes out, it's cooler. It's nice because you do a lot of sports in space, so that you get warm. It's nice to have some cool air. So we regulate the temperature very well in the space station. Now you must imagine we have a lot of machines here, and also 6 people, and they all.
Bienvenido al sistema de conferencias.
Normally you cool off by we don't have air outside, so we have radiators to get rid of the heat. So it's we produce a lot of heat and we get rid through these radiators. But it's very nice. It's very pleasant to be here in your t-shirt.
Thank you so much, André. We're back with our friends in Spain. We'd like to go to them for their next question, please. Spain, ask your question.
Hello, Andre. My name is Mariluz, and my question is, how does the absence of gravity affect the immune system and cell growth?
How does gravity upset can you repeat the question?
How does the absence of gravity affect the immune system and cell growth?
The immune system.
That's clear. We had some disturbance. Yes, that's a very good question. It's one of the first things that people discovered that the immune system in the immune cells, just the cells that protect us against bacteria, are doing less good, and so we have a problem because bacteria are doing better. And also because of the stress, the strange environment, the hard work, astronauts are a bit prone to have a less functioning immune system. There's a lot of research going on with single cells, but also with blood taken of the astronauts and see how they react. There have been experiments to see how vulnerable they are for viruses. So it's indeed, there is an effect on the immune system. Now, astronauts are very healthy, they're very much controlled, they are also in quarantine before they go to space, so we don't have diseases and epidemia here, but of course it is an issue, and there's a lot of research going on over the whole world to investigate what we do with the immune system and what we can do against the problem.
Thank you, Andre. I hear we have only about 2 minutes left, so I hope we can get in some other questions. The Netherlands. Your next question, please.
Hello, I'm Frank from the Netherlands. Do you have to watch out for satellites or meteorites?
Thank you, André.
There is of course a lot of other satellites around, but there's a lot of space in space, and everything is controlled. Big objects, we know where they are, so we can even move around, so move up or down a bit to avoid it. And we have special shielding on the outside of the space station to protect us, and we train very much that in case there is a little hole and air escapes, that we can quickly close the hatches. And in emergency, we can even go to our Soyuz and leave. But luckily, these things didn't happen yet.
Thank you, Andre. We have time for one last question. We go back to Germany. Your question, please.
Hello, Andre. I'm Leonard. Could you describe the launch aboard the Soyuz spacecraft? Was it noisy and was there a lot of shaking?
Noisy, but you have a helmet on and a headset, and so it's very doable. No big problem. It's shaky, but not as bad. I understand like it in the space shuttle. So in the Soyuz it's pretty smooth, and you are in a very good seat. So it's very interesting. The landing, going back to the atmosphere, is much more stressful. You get more G-forces on your body, and that is a very exciting ride back. Also because you have been weightless for half a year. It's so nice to be weightless. You float. It's a bit like floating underwater. So it's very relaxed. But then you come back and you become 4 times as heavy in the Soyuz after being weightless for half a year. So that's very stressful to come back. But it's a great ride, and yes, it's one of the most exciting things of the space flight.
Thank you so much, Andre. That's all the time we have today. We're going to open up the site's microphones so they can all say goodbye to you, and I'm sure you'd like to say goodbye to them. Thank you for having us on board with you today.
Thank you.
The station, this is Houston ACR. That concludes the event. Thank you.
Gut, alle waren prima. Vielen Dank. Einen großen Applaus hier für die Sprecher, die drangekommen sind und die geduldig gewartet haben.
Some of them. I learned a lot today and had a lot of fun. I hope you did too. I would like to go back to our friends in Nemo in the Netherlands for some final words.
Well, Melanie, it was very exciting. We enjoyed it a lot, and yeah, it's a pity we couldn't ask all the questions, but it was great fun and a unique event to be a part of it. So thank you very much, and I hope to see you next time. Bye.
Well, thank you very much. We would now like to go to our friends in Speyer in Germany. We had a lot of fun. How about you?
Yeah, we as well. The whole day was filled with exciting experiments and impressions, and I think the time away from school was really worth doing it. So all the 230 young professionals that want to become astronauts now, give us a cheer. Hey! And goodbye from Speyer.
Well, thank you very much, Reinhold. We'd now like to go to our friends in Granada in Spain.